Hello everybody, Sam here from sassycloud.com. Today I'd like to do a video on how to encrypt secrets in production. It's an often asked question on the net, and what I'd like to do is create a fully working POC that demonstrates some of the concepts that could be used. One of the ways of doing it anyhow. I'll tell you, I'm just going to switch gears here, show you my desktop. So I'll tell you what kind of compelled me to do this. A couple of months back, there was a breach with a telco in Canada, TELUS. A couple of things caught my eye on this one. One of the things was the hack was actually their GitHub private repository. So they were storing, I guess, company data in there, employee confidential records, all that kind of stuff, which was kind of surprising. And the second thing about this is my provider. So I've been with them for like 25 years. So that's kind of what compelled me to do this video. And I thought it would be a good thing to do. It's a question, again, that's asked quite a bit. So let's take a look at some of the goals for this POC and what we want to get out of it. So first one is I want to stay within the confines of the .NET configuration system, using app settings with transforms and such. We want to be able to use a certificate, a password protected certificate, along with a symmetric key to do the actual encryption, decryption of the file. We're going to use self-signed certificates so that we can generate these, on demand. We're going to use, so the target operating system is going to be Linux. It has to have a system D version of 247 or above. Otherwise, the encryption features won't be available. So we'll go over that. We want to leave SE Linux on, so secure Linux for sure. We want to maintain enforcement on that. Again, any of these techniques can be used with any tool chain that has similar settings, patterns, or requirements, and you don't want to store stuff on the server unencrypted. And you definitely don't want to be checking this stuff in to source code control. And a final thing, KISS, keep it simple, sailor, or for new generations, keep it simple, stupid. We want to keep it as simple as possible. And so out of this POC, one of the big things, again, we want to achieve is we don't want to be checking these things into source code control. That is a problem that a lot of companies have more often than not. They don't really have a secure way to handle these things, and just to give access to these things, on a need-to-know basis within the company. So as far as the secrets go, as secrets files, they have to be maintained. If you have an ISO 27001 practice, you should have this defined in your policies and procedures manual. And I mean, you can define whatever you want in the company, but it's important to protect those things and to really only give access to people who really need to know. So any deployment officers, anybody who's in charge of the continuous integration, if you do it that way. We're going to do a deployment from a deployment machine, and we're going to automate all that in this video. So we'll get to that. But it's important to protect those since they won't be in source code control anymore. You have to protect those secrets. So let's get down to brass tacks here. I'm just going to put on my spectacles, and we'll spin up Visual Studio here. So what we're going to do is the POC is going to be a simple generic host console app in .NET 7. Actually, we're going to use .NET 6, and we're going to multi-target from the library to show multi-targeting as well. So I'm going to create the app here, and I'm going to aptly call it POC3 for lack of a better title. Pretty direct. So I could use .NET 7 here. I mean, this will work. You don't want to use .NET 5, obviously it's out of support, but the library, the crypto library I'm going to have is going to multi-target. So we'll just do .NET 6. And we'll create that guy. Okay, so here we have our kind kind of our bare bones hello world. So first couple of things we're going to do, and I'm going to reference my other POC here so we can quickly go through this. So we're going to need some dependencies for sure. And I'm just going to grab those. Read out of the other project here. So we'll just go. Siri log. So I'm going to add some logging to this so we can do debugging. Kind of handy. Go to browse here. So we'll need Siri log. Take that guy. The extensions .logging. Extensions.hosting. And the settings.configuration. And we'll need 2 syncs. We'll use the console in the file. Siri log. Use the file and the console. Okay, I think that's all we need for that. Okay, next thing we're going to do is, and we can do this in any kind of order, but we're going to add the configurations. That's really important to this POC. So we'll go to configuration manager, create, so we'll have a dev Linux. And we'll have a test Linux. And a prod Linux. So that'll kind of take care of our configurations. I probably should have done this after. We do have to add a library, but I think we'll be okay on that. Now I'm just going to take a couple of files that I require. And my other project here. And we'll just copy those in. So what I put in here is, let's talk about the runtime file. So I find this pretty handy to bootstrap if you want your environments, you have environment dependent code. I use macros to determine what we're compiling against. So it's very effective. If you don't have immediate access to settings or anything like that, I just put it in line here in a static constants file. So as you switch this, you'll see it'll conditionally compile what you need, the environment that you want. So that's what that's for. And then we have some various constants here. So here's all of the different environments. There's some in here that we don't use. We'll be interested in mainly these guys here. Some other things including the app settings files names. I've just constant those. Creds directory, that's for systemd. That's going to be very important, and you'll see as we go through this. And then some other things related to the secrets. I do a lot of defaults here, so you can optionally pass in when you use the utilities, the encryption library. You can optionally pass these in, but I set everything to defaults. And as you can see, this is a holdover from the POC, my second POC that I worked on. So we're going to change that as well. Probably do that right now. Just go here. I'll just add another guy. And the reason why we state the application is because we can have multiple applications access the secrets directories at the same time, so we don't get any name clashes or anything like that. Okay, so we should be good on that. I'll just change that while we're at it. There we go. Okay. So the next thing we want to add, now let's take a look at the json.global. Okay, so I'm compiling, even though this is a .NET 6, I'm using the latest version of the compiler that I have on here. And you have to do this if you have a library that multi-targets. You couldn't just put the version to 6 here because you will get troubles with the CLI when you try to compile. So you'll need the latest version of the compile specified in there. That's kind of why we have that. I guess what we can add next is our settings files. So those are important as well. So JSON configuration file. So we'll call it app settings. Put that in there. Okay, so we've got a bunch of things here. We're not going to use that stuff. I'm just going to copy some stuff over. Your POC. Put that in there so you can see we've got the Serilog stuff, but much of the stuff that we're going to be interested for this POC is going to be come out of this setting here. So we'll have a bunch of things in here, including some arrays, which will help us demonstrate how the flattening of the JSON settings will be used for the adding it and merging it into the JSON settings configuration. So we'll fill that in shortly. But for now, one of the other things you have to have is you have to have the slow cheetah NuGet and as well as the extension installed. And the extension helps provide a bunch of tooling for transform. So you can see I have that there. So make sure to install that extension under extensions. And of course, we'll have to add the NuGet as well. I'm a big fan of the slow cheetah. Now, before Microsoft came out with their version, I used to use the previous version here by Sayed. And now I just use the Microsoft one. So we'll install that. Okay, so that gives us the ability now. Let's just check if that will work. So according to all of our configurations, and that's why we had to add that first, we can now add transforms for those configurations. And you'll see it creates a nice hierarchy for us. We don't really need debug and release, but they're part of the configuration, so it added that. So now I'm going to take the settings from the other POC and I put it in here. This is the dev. We'll do test. And we're going to fill in the specific settings after. We'll do prod. Okay, good. We'll just do a clean build here. So we're missing, of course, some references. So what I'm going to do is I'm going to go to the previous POC and I'm going to copy these fellows here. Put that in here. Create a solution file to organize one of those. Put that in there, and from here we'll add our utility project, which will help us with deployment. And that will be this guy here. This is a console application. I started it like that. It could have been a library, but this will be using to assist us in deployment, and we'll get to that in the second part of the video here. And then we want to add our crypto lib as well. And the crypto library is the library that will do all of the encryption and decryption, certificate management, and the symmetric stuff as well. So add that fellow. And then we're going to want to add a reference, project reference to the crypto lib here. And we're also going to want to do the same. Yeah, that's already added, so we're good. Okay. All right, let's take a look at our targeting. Our targeting is good. So if I open up the project file of the library, you'll see I multi-target. So it's kind of handy. I was experimenting a lot with that with .NET 6 and .NET 7. I had some requirements to do that, so I thought I'd just include that in here. Now, I'm going to close out the project solution here. POC3. Should get all of our, yeah, all of our yellow triangles go away there. It's just the tooling thing. Okay, so let's see if it actually compiles. Okay, we have a fully compiling system. So basically I borrowed the code from the other POC just to make this quick. Don't need to do things from scratch here. So we have everything we need here, except for the secrets. So that's the next thing we want to do. And there's a very specific way to do this. So if we head out to the, take a look at where the POC resides. And we'll go here. Just gonna pull this up here. There we go. So we see we have the POC here. I'm going to go up a couple of directories, and you can see I have this secrets directory. So you can use any kind of system you want, but generally what I do is I put the secrets files out of band, and then I will add them to the project as links. So if we go into the secrets file, and you'll see why everything's partitioned by the application. So you can see I did a few POCs. I went through the exercise a few times just to get everything right for doing the demo. So you can see in POC3, I did take the liberty, so I have some secrets in here. So if I add these files, we'll add them as links. So we'll go right to the POC3, and we'll add existing items, go up a couple directories, and there's our secrets. We want the ones we want. That. And we want to add all 4 of these. So that's the base secrets for the transforms, and then these are the individual environment specific stuff. Well, we have to add those as links. So it adds them. Doesn't add them quite the way we want. If we take a look at the project file, you'll see it adds it in this little format here. And we're going to have to change that a little bit just to get Slow Cheetah to work with it. And what I'm going to do is I'm just going to copy again from the project over here just to make these things a little quicker for us. I'm just going to put it side by side so you can see what I mean. We have to get it into that format there. So basically, we needed to add the transform stuff in here along with, now if you separate this stuff out into another item group, the transforms don't quite work properly. So I kind of settled on this. I experimented with it for a little bit, and this works for us. So what I'm going to do is I'm just going to, same paths, so I'm just going to get rid of that. Control H on that. Let's see, 3. We'll replace all that. And if we save that file, you can see on the right-hand side in our tree view, we have that nice hierarchy now. Now, if we take a look at that secrets file, you can see where I filled in the connection strings here. And I put some other stuff just to demonstrate using nested arrays and just multi-level JSON type format settings, because we're going to need to flatten this file in order to get it into the configuration system, and I'll show you that. So if we take a look at the Dev Linux one, you can see it's different. You can see I have a JDT replace here, which does transforms for us. You have to kind of do it this way because the arrays are not really strongly named, and the transforms has a problem merging them together unless you actually specify the path in a replace tag. So if I right click on that and I go preview transform, you can see it does all the replacements for us quite nicely. And this is the kind of system I wanted to maintain with this POC. We don't want to go away from this because this type of stuff is really time saving, especially if you have hundreds or if not thousands of lines of configuration, some of which that may be secret, that you don't want to have it on the server unencrypted. So now we have that. And if we do a build, if we just do a simple build here, we'll do a cleaning to build. We'll take a look at the output directories. We should have a transform secrets.json file in the output. So we'll go to, we were on dev Linux, so we'll go to devlinux.6, and there's our secrets file. Of course, defeats the purpose if we publish that to the server. So we're going to have to, during the deploy script, we're going to have to do some manipulation to encrypt this and only deploy the encrypted version. And we'll do that when we get to the automated deployment part, which is coming shortly. So we have our settings. Now, let's talk about this secrets again. Generally, we're doing it from a deployment machine, but you could have this in a CI if you use Jenkins or any kind of DevOps, Microsoft DevOps, any type of pipelines type system. You'll have to work out, you can adopt some of the scripts that we're going to have here. You'll have to work out how and who has access to those secrets files and how they'll actually be used and deployed, encrypted and then deployed. So, so again, if you have an ISO, if you're implementing ISO 27001, you'll have policies and procedures for this. So it'll be in your manual and it'll be clear instructions on who has access, how that access happens, how the deployment happens, your whole promotions process through the various environments that you have. For example, in our company, we encrypt everything in all environments. So it's not just production. So this applies to any type of environment you have. You could have UAT, you could have staging. In our sample, we have dev and test and prod. So it's important. I just wanted to add that and just kind of highlight that you really need to protect that. It's also important to note that when we add this POC to source code control, these will not be added, which is exactly what you want. And the reason why we partition them like we did here with the multiple applications is obviously it's not in source code control. So when you check out different branches, or if you have a branch per customer, for example, we have that for some of our customers where we have the mainline base code and we'll have a branch for the customer. Of course, because this isn't source code controlled, it's not going to switch gears for you. So it's going to kind of be static. That's why we have the links to the different various applications here. So that's kind of why we order it like that. And so, but Visual Studio will not add those because they're links. So that's by design. So that's kind of what we want. So now that we have the project all set up and I've kind of explained how the transforms work, the other thing to note too is that these two settings do not directly tie to each other yet. We have to merge them in. So what I'm going to do is we'll close out all these windows here. And I'm going to open up program. So we have nothing in our program right now. So let's copy over the good bits. I'm just going to get this from the other POC. Copy that in. Might be some stuff that doesn't compile yet. And we're going to make this. We don't technically don't need to, but I'll copy over all of the usings here. And I'm going to just kind of use the new feature. So that's a nice new feature within Visual. I'm not sure which C# version is, but you can flatten your namespaces now. You don't have to enclose them in braces. So that kind of saves you a little bit on spacing. I think we're going to have to use POC3 in here. Right. So we're going to have to fix that. So I'm just going to do a find and replace in files here. Again, this is what happens when you cut and paste. POC2. Oh, better spell it right. POC3. And we'll replace all of that. Let's see what that did. There might be a few things it didn't do quite right. There we go. So it did switch a few of the things around. Let's go to application, fix that up. Of course, I can just get rid of that. We'll just do POC3. Okay, let's build that, see what we get. Here I'm going to be missing probably missing dependency, so we'll go into that. Let's go back here and see what it says. Oh, right. I know what I'm missing. I had an extensions file that I did for the POC, so we'll just add that guy. And we'll have to change the namespace on that. POC3. That should take care of that error. And we'll compile again. Should be good to go. All right, so let's take a look at the meat and potatoes of what this POC does, and it's all going to be in program. So what we do is when this starts up, we want to be able to decrypt the file. Essentially, this line here does that. You can see when we're not in debug mode. So we can run this locally on Windows if we select the debug, and then it'll simply merge in the secrets file here, and without decrypting it, because you don't need to do that if you're running locally and debugging. But if we're deploying for Linux, and we'll select Dev Linux for that, we're going to need, on startup, we're going to need to decrypt that file. And that file will actually be, the default name of it will be secrets.json.enc for encrypted. So it will decrypt that file. It will get it as a dictionary, but this will be a flattened dictionary. And I'll go into that, why we need to do that. And the fact that we need to change the format a bit to match .NET's flattened kind of key pair representation. So basically we get that. And when we access our settings, we use this add in-memory collection. And that will merge in all of our secrets that we have here for us. And that the format of that dictionary, again, is going to be a key pair that's going to be flattened. And we use, if we go to the library, let's see what we got here. We use JSON flatten for that. Now, there is a few things that we have to do to kind of fix up the JSON flatten. It doesn't use quite the same format that the .NET configuration management expects. So, so we have to flatten it in that way. So once you've added that, what we do is we build it, and you wouldn't do this in production, obviously, but we output some debug stuff to demonstrate that we did successfully decrypt the file. And again, this is all running as a systemd service. So we're going to show all that. So this output should correctly show the various settings. In this case, we're going to deploy to Dev Linux, all of these various secret settings. And keep in mind this file, these will not be deployed to the server. So that's basically the meat and potatoes of this. This is a generic hosted service, so it'll just run and just wait for a termination signal. It doesn't do anything other than demonstrate what we wanted for this POC. If you see this here, and you're asking yourself, well, this is supposed to be cross-platform. This call is cross-platform. Don't let the name fool you. The designers decided not to change the name. I think there used to be a use systemd, but they decided to unify everything. So this works very well on a Linux systemd service. So don't let that fool you. And that's essentially it. So again, this could be adopted for any type of project in .NET, certainly. So if you have a WPF, if you have a web API project, if you have a MAUI project, anything, this could be adapted. Same kind of pattern if you use app settings. So other tool chains have settings, the concept of setting files obviously too, so you can apply these concepts the same. As far as the cryptography goes, what I'd like to do first is we'll take a break, and in the next video we'll set up Linux, get the service set up, go through all the trials and tribulations of dealing with SE Linux, get the service, get system.creds, get that encrypted so we can encrypt our master password that we're going to use for the certificate, and get all of that running. And then we'll go to the automated deployment script. It'll be a PowerShell, a cross-platform PowerShell script, and we will get this stuff deployed and get it running. Until then, see you then. Hello, everybody. Back for part 2 of encrypting secrets in production. Before I get into the subject of this part, the Linux configuration and systemd, I'd like to go over, just for some continuity, just go over the code a little bit and talk a little bit exactly about what we're doing here and how the decryption process works. So I'm just going to drag this over here. So the POC itself is just a generic service host. It's a console app. And what's happening here is on startup, systemd, the service that we're going to set up later, provides an unencrypted password for the certificate. That's the self-signed certificate that we generate during deployment. Then what we do is we use the cert to decrypt the symmetric key. So that's also automatically generated and deployed to the server. Then we use the key to decrypt the actual secrets file. So that will exist on the server as this. That's my default name. That's what I use. And then because the add in-memory collection in .NET uses a slightly different format of representation of keys and the hierarchical settings, we use JSON flat, and then we have to adjust it a bit before we actually put the dictionary into there. So that's the process of what's happening. So the first thing you might ask is, well, why don't we throw all of the secrets inside systemd? And the answer is you could do that. It does use symmetric encryption, so it's fast. Of course, one of the goals of this POC was to use the existing .NET app settings pattern. So, I mean, you'd have to configure each server, each environment, and you could script it, but I mean, you wouldn't be using this facility to do that, and everything would be in one place. And that leads to the second question is, why are we using symmetric, asymmetric? Why are we using a certificate? Why are we using all in combination with systemd? Well, that was the goal of the POC, was to kind of demonstrate those concepts. And again, you can do this many, many different ways. I wanted to layer it, and I also wanted to use systemd's facility for providing secrets as well. So, if any one of these components are compromised, you're not going to get all the secrets. You're going to have to jump through some more hoops. So, for example, If the master password was somehow compromised, you'd still have to get at the certificate, and you still have to use the certificate to get at the symmetric key and then get at the file. So there's different ways you can protect these artifacts on Linux. One of the things Nginx does, the web server Nginx, is it starts up as the root process and reads the certificate in as root. And so therefore the certificate can be stored under etc pki or wherever it is on your Linux distro. And then it forks out all the processes for the actual web server. So we could do something similar like that. We're not going to, it's beyond the scope of this particular POC, but we could put the certificate in a different area that can only be accessed by root, not just the service count. So these are the reasons why you kind of split it up into the components, as well as to demonstrate the different concepts going on here. So let's take a look at the code just for some continuity. I wanted to go through this. So this is the big call here where we actually get the dictionary from the encrypted file on Linux. So let's step in here. So this is a helper class here where I kind of gather all my constants on the client side to pass into the library. But this first call here is very important. So this is the one that actually gets the secret material from the service. So this, in our case, this will be the password, the master password for the certificate. I put a little important note here. The way this class reads in on Linux, there will be some line feed characters. It could be, depending if it's a line feed or a line feed carriage return. Under Linux, it's always a line feed, but there'll be a character like I believe it's a caret $sign. I'm not sure, but anyhow, I had to trim that off. Otherwise, none of the decryption worked. Obviously, it would throw it way off. So that's just an important little note there. Make sure that you have that in. So that reads in the unencrypted password for us. And when we set up Linux, we'll kind of look at where this is stored. It's actually mounted on a memory-based file system. So we'll take a look at that. So that's our password for our certificate. So now we actually call in, and this is a static version of this. Oops, this is a static version of this method, but I also provide, you can also inject this deploy utils class. Just for the POC, I kept it simple. So this method receives the certificate file name, so that has to exist. So the certificate would have had to be created, and it has to be on the remote server. There's the password we talked about for the certificate. Then we pass in the path of the actual encrypted JSON file. So that's going to be this little fellow here. So that would be our transform file for the Dev Linux environment. And let's go back here. Then we pass in the path and file name of the key file, which is also encrypted. So that'd be the symmetric key, the AES symmetric key. And then this fifth parameter, we'll just go to that here. So it's just an array of the names of any arrays within the settings file. And we need that so that I can easily reformat the flattened JSON file to the format that .NET likes it. So if you take a look at the file, if you have any arrays in there, you're going to need that so that the flattening method could appropriately reformat the key value pairs for .NET. So that's what that's for. So let's go back here. Okay, so now what we'll do is we will jump into our implementation. So this is where all the good stuff happens. So this is in the library. This is the static version. There is a instance-based version you can do to inject this class. So the first thing we do is we instantiate this little AES helper class, which is I took from Damien Bowden's really good article here, and I put the link in there. I'll put all these links into the video links as well, so that everybody can have access to this easily. So these are a couple of helper functions to encrypt and decrypt. So have a read of that article. It's an excellent article on symmetric and asymmetric encryption. I also use the certificate manager NuGet from from Damien to generate the self-signed certificates. And we'll talk about that after when we do the deployment stuff. So let's get back here to our main method. Okay, so we load the certificate using the X509 Certificate 2 class, which is a .NET framework class. So we load that given that password that we read from systemd. Then what we do is we read in the contents of the actual encrypted file that we want. Now, I didn't mention this before, but the initialization vector from the AES key material, I prepend that to the encrypted file. So here we're stripping that out. And we have to take the first 24 bytes of that to get that initialization vector. So it's like a salt. Then we get the actual contents itself. So we have the input, the initialization vector, and the contents. Now we need to get the key, the symmetric key that we're going to use to decrypt the actual settings file. So we have the encrypted key path and the certificate. And from that, we can decrypt the key. And once we get the key, we can now decrypt the actual contents of this file. And that's what we want to get to. So once we have the decrypted contents of our target file, we're going to need to flatten it out like I talked about. So let's just take a quick gander at that fellow. So you can see here, because I have arrays, I need those array names just to keep the method simple. So I just use a little bit of link here. We flatten the file using JSON flatten. We convert that to a dictionary. And then we loop through and we massage our array elements here. So JSON flatten uses this format, uses a square bracket. We have to replace that with colon so that the hierarchy is represented correctly for .NET. So that's what this method does. So you can take a look closer at that and how that works. So once we have that, let's go back to our program. So now we have our flattened dictionary for use in our add in-memory collection. So that will appropriately merge into all of our existing settings files, which are, any of these settings up here. So any of this. So this will hydrate this section. And after that, to prove that we achieved what we set out to do, we build the configuration. You don't have to build it here. The only reason I'm building is because I need to access and output these values. Of course, you wouldn't do this in production. This is just for debugging only. So we're proving, so it should output the service when the service starts up in systemd. It should output the default connection string, which is secret. And then we drill down into some other nested keys and into the arrays. I wanted to go into the arrays just to demonstrate that as well. Just so you have, not just a simple settings file, but you might have a lot more complex hierarchy in your settings file. So that kind of demonstrates that. So in a nutshell, that's how everything works. Now what we want to do is we want to get this guy deployed to the Linux server, set up the service, deal with all of the SE Linux, and get that all working. So we're going to do that next. Okay, so let's get Linux set up now. So I mentioned earlier that we need systemd version 247 and greater. So anybody who's running any Red Hat flavor like CentOS, Rocky, Alma, that's below 9, you're going to be a little disappointed because it won't be available. So you'll need to install version 9 or higher of CentOS, or I'm using Rocky here, so you can see I'm using the latest patch version of Rocky OS. Yeah, 9.1. So we can check the version of systemd. So you can see this particular version is running 250, so that'll be sufficient to run systemd system-creds, and you should get a response. If you don't have that, then you'll get a command not found. So that's one of the caveats is they just came up with encryption for systemd well, relatively short while ago, I guess. So you'll have to have version 9 or higher of any of the Red Hat flavors. So let's start with, so we're fully patched, I believe. I think we have anything to do. So let's create the service file. And what I'm going to do for that is I'm just going to service file. Now I'm going to cut and paste from a previous POC here, service file. Let's see, we get everything we need. I think that's good. So we'll paste that in. Okay, so this is a typical service file. So as you can see, we've titled it POC3 for lack of a better title for our POC. We're starting you can see where the output directory is going to be here, and that's going to be important where the executable runs for the deployment. So we're going to deploy to actually this directory off of root, POC3. Normally for debug purposes, I set this to no, at least initially, because as you see, we're going to have some issues with SE Linux on this when we first start it, and we'll deal with that when we get to it. We got a syslog identifier, POC3. The user is going to run under a service account called POC3. We've got our typical environment variable here. We set to dev Linux. Don't print out the telemetry message. And then this little guy here is, that's the actual encrypted master password for the certificate. Of course, you can see I copied this from another service. So what we're going to do for now is we're just going to kind of get rid of that. And save that out. And what we'll do is we'll get the rest of the infrastructure in place here before we do this. I'm just going to put that up a little bit. You guys can see that font. So the first thing we'll do is we'll create a service account. And we'll do that. So that'll create a service account for us, I think with a no login. And that's what we want. You could use an LDAP account here. We're just going to use a local one for our purposes. I'm going to create the directories here that we need, and I'll explain each one as we go. The actual setup script will create these if they don't exist, but we're going to set them up just so that we can talk about the different parts of where the different artifacts go. So we're going to make a directory called off the root called scpriv. That's where the any private stuff is going to go. And in our case, it's going to be the symmetric key. And we're also going to qualify it with the application name because you could have multiple applications running on this server. So we'll do. Oh, yeah. Going to need minus parent in there. Here we go. Minus B. So this is the certs directory. So we're putting our certificate that we're going to use inside another directory off the root that's going to be permissioned on the service account. I did mention before you could potentially put this into the under etc PKI on this distro anyhow, where only root has access to those to that certificate. So we'd have to do a few things differently in the service file. It's a little out of the scope of this particular POC, but we're gonna put our cert in this defined directory here, like that. And what we're going to do is ownership to this. I'm just going to put commands already here. So we'll do that. change the ownership for that. And we'll also do the certs. Now, again, the startup script does that, but I wanted to show everybody where we're putting things. So we'll manually create them for now. So we've got that, and then we're just going to change. Let's see, 3. Change the permissioning on that. Certs. There we go. So essentially, what we have is, so essentially what we'll have is we'll have all our applications that we need to put any key material or the symmetric key underneath that directory, and then all the certs will go under that directory off the root. Okay, so the other directory we should probably make is the actual where the executable will run off of. And normally, I mean, this could be anywhere. In the case of a web server, it'll be under var www HTML or wherever you might have it, but we're just going to have it run out of, and we're going to deploy it to this directory here. Let's change the ownership on that to POC3. Don't have to do recursive, but we'll do it anyhow. And we won't worry about the ownership. We don't need the permissions for that. Okay. So now we have the service file, we have the service account, we have the service file created, we created our directories where our artifacts are going to go. The next thing we need to do is deal with system-creds, system-creds. So as I mentioned before, we're going to use that utility to encrypt our master password. And I'm just going to go, I'm in its root rate, sudo is root rate now, so it's going to take a look here. I'm just going to create a little file called pass.txt. And do that, I already did that. We're going to use a pretty simple password for the master password, and we'll call it, for lack of better, we'll call it master password, my master password 800. So normally you'd have a long password in here, but I have to caution you, do not use, paste these characters, do not use those characters there. And I'll have this in the documentation and on the GitHub repository in the notes, but what will happen is you'll get all kinds of escape problems with system-creds, and it'll be real frustrating because you won't be able to decrypt your file, and you'll get all kinds of problems with that. So don't use those characters, but you can use all of the other ones. I just found that those ones particularly gave me trouble. So I'll save this out. So now we have a text file with our secret password that we want to put into the service file, encrypted. So what we're going to do is we're going to run our command for doing that. I'm just going to cut and paste here and make things simple. So I'll paste this in and we'll go over this here a little bit. So POC3, of course I didn't call it. So what this is going to do is it's going to encrypt whatever contents are in temppass.txt. Now, system-creds will use a TPM chip to store the key material and use key material if it has it. I don't have TPM enabled on this particular in this particular environment, but it still will encrypt it. It just won't use TPM. So we'll run this. And as you can see, we get all kinds of warnings and errors about various things. But at the end, you can see it does do the encryption for us. And what we need, the piece that we need is we need to copy this verbatim. So we'll copy that, and we will call up our service file, and we're going to put that in, and we can just right click, paste that in. So this identifier is very important. That identifies the service, and it'll be unique for every type of credential that you want to store. When the service starts up, it actually mounts an in-memory file system, and that's where how it manages the credentials. We'll take a look at that once we get everything running here. So we will save this file and see if we have reload. I can't remember. Yeah, so that's what it was. So we always want to do that after you change a system file. It's pretty annoying. It'll warn you if you try to do stuff. Okay, so let's see. Do we have everything we need for here? I think so. So we're gonna have to deal with SE Linux, but we're not going to be able to deal with that until we actually deploy the service and all the artifacts that we need. So what we're going to do next is we're going to go over the automated PowerShell script I made. But first, let's make sure we have that installed. So the PowerShell I'm talking about that we're going to use is the cross-platform PowerShell. So it's not Windows PowerShell, but it runs on Windows and Linux, Macs, etc., etc. So I don't think I have it installed on Linux here, so I'm just going to go grab. Let's see. I'm going to install it directly from this, and I'll have this in the README as well. I'm going to get the latest release here, I think, that's available for us. Let's see if that installs. And it does. So we'll go yes. Install that. Bit. There we go. So we've got our, so that's, we're going to communicate over SSH with PowerShell because we're going to be using PowerShell to deploy. So we're using a remote session. On the Windows side, now I use Windows Terminal, which is a very handy utility from Microsoft. It has pretty much will package up all of your CLIs for you. So you can see I have a bunch here. I get the Windows, PowerShell, obviously, the built-in Windows command, CLI, the Cloud Shell for Azure, Git Bash, Ubuntu, all the other stuff. This is the PowerShell here that we're going to be using. And I think I have 7.2.10. I think that's long-term service. But what you can do on that is if you don't have it installed on that side, what you can do is you can use winget. Yes, I want to paste that. So winget, you can actually get the package and install it. Well, they'll show you which ones are available. It looks like they're up to 2.3.4 now. So anything above 7.2.x should do for you on either side. So if you want to install that, you would just simply use this command. Again, I'll have all these commands for you in the documentation, but you basically, you don't want to install a preview, you want to install the latest release. So you'll need both of those on both your Windows deployment machine and your target OS. In our case, it's Rocky OS. So next, what we need to do is we will need to go through the script and create the script. Okay, for the deployment script, we're going to use PowerShell, and I'm just going to add that to our POC here. We'll add a folder, and it's called it scripts, and I'm just going to drag over our scripts that we have here from my previous POC. We'll put that in there. I could actually call that deploy POC, because we're going to make it, it's the script is generalized. It'll accept different application deploys. So we're going to do that. And there's one other thing that we forgot to do on the server side, and we should do it now before we forget. Otherwise, when we reboot, we'll have that much fun. Okay, so we created the link. We won't enable it now, or we won't start it now, obviously, because there's no executable code anywhere. So take this guy out of here. So in order to automate all this stuff, because it's quite a bit of work to put all the artifacts together, generate the certificate, generate the key, encrypt it, do the transforms, all that kind of stuff, I created a cross-platform PowerShell script. And so we can go through it here. It accepts a number of parameters. So we'll just go through the parameters quickly. So the first one is the application. So in our case, we're going to have POC3. We're going to actually add that to this. We have the configuration. So that'll be the configuration, your target build configuration. Okay. The framework, target framework. So we're targeting .NET 6. And okay, so the SSH user. So we're going to deploy this over SSH, standard SSH through PowerShell. So you're going to need a user. Internally, we do use two-factor. We use time-based OTPs, but I've disabled it for this demo. But you will need your key. So so we have the user, and you'll need your public key or your private key. So if you created a key pair and you log on to your systems via SSH, you'll have that key someplace. And this is for our test key for this particular POC. So you'll need that. You'll need the certificate file name. If you want to generate a new one, which we do want to do every time, just leave it blank, and which is what we're doing here. And the certificate password, that's going to be the master password for the password we put into systemd. So you'll need to insert that there. Of course, I don't have it in script. It's a bad habit to put passwords in scripts. So you'll pull that from your whatever, again, wherever policy you have, wherever you store those master passwords for your certificates, you'll have that procedure, and you will pass it in on the command line. Output secrets directory name. So that, as part of the utility, I do allow, and I'll just show you now, we have a secrets deploy directory. So that's where all the artifacts will get written to locally before they're copied over and deployed. So you actually set that in the script, and you can see I have it set up for my two POCs I did before. I'm going to just set up a POC3 so you can have multiple deploys for, and you can see this was from a previous deploy. So I output the utility. As part of the utility, it will output the key, symmetric key unencrypted, the encrypted version, and the certificate. Does it matter if you lose these? Not really, because you can just generate them again. So what we'll do is we'll go back and make sure. I don't think I create these directories automatically, so I'm just going to do it for our dev Linux here, and we should be okay. So that's what that directory is. If we leave it blank, it will default to wherever, it will default to our secrets directory. I think I have the default in here. There it is right there. So that's the default. And you can see I have a number of other defaults in here that we start off with. For example, the base remote directory, those are the directories we created on Linux. The base encrypted key file name, the private certs directory permissions. I'm not sure why I have that in there. It should be 0. And then temporary permissions, because we need to read and write when we're doing the deployment. So these, you want to make sure these are set up according to your environment. So I'm working off a drive D. It doesn't really matter. I made this, I set the drive because I often have a lot of people work off their C drive. You can work off your D drive or wherever. So I put that in there as a little facility to change. So this is the format of our command that we're going to use when we want to deploy. So let's go through what happens here. So I parameterized this so that this script will work for multiple applications. So you can see here, I have settings in, specific settings for POC2. And I also have environment set for dev Linux. So we set the target IP, service account name, etc. That actually is probably going to need to move out into here because it's going to be application specific. So what we'll do right now is we will create POC3 settings. And we're going to want to change these little guys to POC3. I just want to do one at a time here. Okay. So this will work for our POC2 and our POC3 depending on what we pass in on the command line. So we'll put that up. Now I have to be sure about what we're doing here. Yeah, so the service account is coming from the environments. And I'm pretty sure we're going to need to switch that over. And we're going to need to take that service account. We'll put that in there. And we'll also need the same thing over here. That in there. 3, of course. And then we're going to have to modify. Better do that now before I forget. So this will come from settings. And this will be application. Oh, that's incorrect. We don't want to change that. We want to change this one. Settings. And application. Dot service account. So you can see how I'm accessing into the little configuration object there. Since the application is passed in, we can directly reference that collection, so we can get into there. So it's nice and handy to configure all that. Okay, so let's go back to our settings here. Okay. Working update. Okay, so now, we have the target server. So we're going to target Dev Linux today. That's all we really need to do. This works for any environment. You just have to fill in, for example, you put in test Linux in here. Of course, you can have any environment that you want. I'll leave that exercise up to the viewer. I'll just put that there for now, just as a placeholder. Okay. So then we have a number of functions, one that builds the back end. There's only a back end to this. There's not a front end, such as if you'd have an Angular app, which is generally built differently. So I kind of encapsulated that into a method, into a function. There's some other helper functions here that we use, getting the remote service status, starting the remote service, stopping the remote service, copying the back end to the remote over SSH, temporary ownership change, creating the remote directories. I told you that it defaults to do that. We created them already, but it does, the script will do it. So this basically is where the script starts. So we set some defaults here. We crap out if we don't get the target server correct. So it'll begin with a local build. So it'll clean it. We take a look at that function. It will actually clean the directory first. It will publish it. And notice here we are also building the the data protection exe, and the reason is publish under Linux targets don't know the concept of exes, so we build it specifying that just for this utility, because this utility doesn't run on Linux. It runs locally so that we can deploy our application, generate all the artifacts and such. So that's kind of why we're doing a two-step here. So that takes care of all of that. We check to make sure that some certain variables are not, for example, if we pass in the default, our empty will default to whatever we set the default for certain variables. So in this case, the secrets output directory. We calculate the output directory based on the configuration and the application. And then we start the process of creating the PFX file. So let's take a look at I encapsulated a couple of those functions inside a module. So you can see it here on the right side. I've got the module included, and this will all be packaged up and included in the GitHub repository. So you can see here we create the PFX file. So this will use this will call the data protection utility here, which runs locally as a console app, and we just pass in parameters that we want to the console app, and it will create this particular function will create the certificate for us with the password. Then, given that if we go back to our deploy script, if that's successful, what we'll do is we'll generate the secrets file and the key, the ASE symmetric key. And you can see we call that module method right here for that. So that will create those artifacts for us again to our default secrets deploy directories, which are right here. So you can see in the previous POCs, we have these artifacts that are generated. Now, only this artifact and this artifact will be copied up to the remote server. Okay. So once we've done all that, you can see here what will happen is I'll remove the secrets file. So during the publish, this secrets file will get transformed and it will get put to the output directory. We want to now remove that because we're not going to copy that file up to the server. So that's what that's doing. Next, we actually log into the server. So we use all of our parameters that we passed in to log into the server. And if we're successful, you'll know right away. It'll stop the existing service. So that would be the remote POC3 service. It just sets the remote private and search directory. It will create those directories if they don't exist. Now we need to change the ownership. So we execute a remote script command over SSH using our session. And you can see here, because we're logging in as my account s.mariel, we do sudo, because I have sudo access. And we'll change the ownership in all those directories so we can actually write to them. We will change those back. So that's what this is doing. Then we copy the backend to the remote server. And I find the copying over PowerShell over SSH is a little bit slow, but I mean, it works and it's automated, so I'm not going to complain too much. Then what we do is we copy the artifacts, the key file, the encrypted key file, and our certificate over to those remote directories that we created. Then what we do is we restore all our permissions. And you can see in this command here, we are not changing the permissions on logs and temp. Typically, log file directories and temp directories, you need write access to them. The service account will need, or whatever the runtime account is, will need access to those. So we skip over those. So that's what that command does there. We change the ownership back onto the of the actual executable directories where the application will go. So that's what all this does. Then if everything's good, we start the service and we attempt to get the service status, and we put some nice messages out, and we close out and remove our session as required. So you can change this around however you want. I threw this together, tried to make it rather, relatively parameterized. You can take, some of the code snippets from this and use it in your CI, whatever you want to do. But for our purposes, we want to deploy from our local Windows machine over SSH to Linux. So that's kind of what we're going to do. So we added this, we added the POC3. So the next thing we need to do is we need to execute this for the first time and see what happens. Okay, so now comes the fun part. We get to try and deploy this. Now, I know this isn't going to run when we first attempt to start the service because based on experience, we're going to have, there's a bug in systemd in the policy, in SE Linux policy, where we'll have to add our own policy module, and we'll see how that works shortly. So what we'll do now is I'm just going to pop back to this here, and you can see I was working on POC2 there, but what we're going to do is I'm going to 3 should be there. Oh, I didn't go back far enough there. There we go. Okay. So we're in the scripts directory. We're going to run it out of here. I'm just going to cheat a little and use our last deploy. Okay, so let's take a close look at this. So we no longer call it deploy to. Change that. We know that for sure. Now this is the application. We definitely want POC3. Okay. And the next thing I need to check though is this is .45. So good thing. I'm just going to change that right now before we forget. Our new dev Linux is .45. I was previously deploying it to another server, so I wanted to demonstrate from scratch how to set up this, the service file. So, okay, so we're deploying there. That's our configuration we want. Definitely .NET 6. My username, my key for SSH, no certificate. This is the master password for the encrypted portion in the systemd file. So that's, we need to have that right. And I'll show you what happens if you don't have it right. So everything looks so good. Let's see what happens. There we go. Yeah, I was going to be surprised if it ran the first time. So what we'll need to do, we'll just use that guy, POC3. So we validate the parameters on that right within the script. Save that out. Come back. Try that again. Let's see what happens. Okay, it's building, cleaning, building. Creating the key and the certificate. Wow, that worked the first time. I can't even believe that. All right, let's, it's asking for my, oops, hang on here. What's going on here? Just trying to type SN, it's not currently edit. There we go. Okay, so now, because I went to a new server, it obviously had to pull the public key from it. So now I'm going to log in to SSH to that server, and let's see what happens. Okay. Let's see what we got. Yes, so for some reason it timed out because I kind of fumbled on trying to get and you know, answering the prompt. So what we'll do is we'll go back and cd scripts. Let's just do that so we have it permanently in there. Okay, so let's try this again. That's the beauty of a script. You can just rinse and repeat. So give another try. It shouldn't prompt us for the key, for the server's key now. There's the key, there's the cert, and we're ready to log in. What happens? Subsystem requested on channel 0. Okay. Okay, so the main reason we got that error was because I did forget a step. And what we have to do is we have to add the PowerShell to the SSH subsystem to allow communication over that. So what I did was I created a custom SSH config, and we put in the subsystem directive for PowerShell in here. Once you do that, you do have to restart the service. It's not the service, but start this HD, and then you should be good to go. So we'll drag that out of here and we'll try our deployment again, and we should have better luck logging into SSH. So my bad, I forgot that step. So we'll run that. Everything seems to be compiling. Creates the key, the certificate. And now we're going to log in and see what happens. Oh, there we go. It's copying files over. That's a good sign. Now we know the service isn't going to start, and we'll take a look at that and I'll show you why. Okay, so it even told us that it failed. So let's pull over the terminal for that server and let's take a look. So we'll go system control. So let's first of all, let's take a look at the we got all our files there. You can see the secrets file is there, the encrypted secrets file. Of course, you don't want the plain secrets file there. That would defeat the whole purpose. And you can see the permissions are appropriate for this particular POC. We just want the owner in the group to have read-only access. You know, if you did have a temp directory in here or a logs directory in here, actually we should probably do that. We'll just make a logs directory in there, and we will, first of all, I'm going to have to change to PLC3. Should be good enough, and then we'll change the permissions on that. That could be anything you want. Do 700, whatever. For our purposes, it won't matter too much. There we go. So the deploy script automatically skips over any of those types of directories. You'll have to do a little more setup work to make sure that it has the appropriate directories to write logs, etc., etc. And let's just take a look here. Yeah, so you see the logs directory can be written, you know, read, write, execute on the logs directory. So that'll work for us. So let's take a look at, so there's our symmetric key encrypted, and we can do the same thing for the certs. There's our certificate. So those are our artifacts. That's where we chose to put our artifacts. That's where they were deployed to according to the script. So the next thing is, let's take a look at the status of POC3. And this was expected. So if we can also take a look through the journal, POC3. Take a look at the last 80 lines. It doesn't give us much more, but basically the credentials fails to set up. So let's take a look at SE Linux. We're enforcing. So this is going to be the reason, and this kind of tripped me up because I didn't know about the bug in system-creds, at least with the current version and patching that I have. The policy isn't quite right, so it won't start. So here's the procedure, or a procedure, that we can use to figure out what's going on. So basically, we're going to take a look at the audit logs. And so what we want to do is, the first thing we're going to do is we're going to temporarily set the enforcement to off. So we'll do that. And then we're going to attempt a restart of our POC. So we'll do that. We should, again, it probably won't start for other reasons, but we want the audit messages to get in there. And we can take a look, just a quick look here. And you can see, you see these dev ramfs denials. What that is, systemd attempting all of these denials here, attempting to create the temporary file system to store the credentials at runtime when the service starts up. So what we're going to do is, I've got some commands here. I'm just going to create a separate directory off the root to store our custom module. So we'll do that, and we'll enter that. And now what we'll do is I just want to take a look at the output of audit to allow, a little utility. Okay, so there's our problem right there, our particular problem on this particular OS right now. So what we want to do is we want to create a custom module for that. So in that directory, I'm going to create the TE file. I believe this creates the TE file. And I'm going to call it sc-systemd-creds because that's specifically what it's for. So we'll do that. Now we get the, sorry, pp. Now we have to install the pp file, which is a module. Install it permanently. So we'll do that. It takes a little bit thinking. Okay, so now that module is installed. I wasn't quite sure about whether or not we have to reboot or not, but we're going to do that anyhow. For a custom module, I'm sure there is a way to load those dynamically. We're just going to reboot just to, it takes about 30 seconds. And we're going to see where our service is at. Okay, so we're back after the restart here. So you do have to restart it. From what I can tell from the documentation, if you make a policy change like our custom module, while SE Linux is disabled or not enforcing, as far as I can tell. So anyhow, just to be safe, we rebooted and we'll log in and see where our service is at. So I'm just going to go root here and we'll system control SPOC. Okay, so still not working quite the way we planned. So let's service. Time where these things go. So let's take a look at what we got here and make sure everything's right. We've got our POC3. That's what we need to check right there. Definitely we need to check that command. I did have problems with when updating .NET, it changed the location, or the soft link wasn't there. It wouldn't run the command correctly. Otherwise, that looks okay. So we'll get out of here and let's do a journal. Right, so that it just tells it right there. I should have looked closely. That's what happens when you don't read stuff. Which .NET? Right, so it doesn't seem to think that it has, and that may be too. Info. Yeah. looks like nothing is installed. I guess it's not really going to run. So what we're gonna want to install is we can install. I usually install the SDK on you know, develop non-production machines. So you get all the good bits for that, like the ASP.NET Core, all that stuff, even though this application is only a console app. So what we'll do is we'll install the 6.0 version. So you can see all the dependencies it pulls in, the runtime and all the good stuff. So we'll say yes to that. And I think I'm going to do 7 as well. So we can both live together side by side. Installs fairly quick. It's always nice. Let's do 7 as well, just for fun. Okay, so we should be good now. So let's give it the service a try. C3. And let's take a look at the status of that guy. Still okay. So we're still not finding that .NET. Okay. Yeah, that's probably not going to do it for us. Okay, that's your problem there. So this is what I encountered before. There isn't a soft link to this. So the installer typically does that for you, but I found sometimes it just simply doesn't. So, which is not all that fun. Let's take a look at this fellow here. I think this is a link. It is a link. Yeah. So I'm not sure if they changed that or what exactly their thinking was along that line. But what we can do is we can also do a link soft, and I can do that. Wondering where that is. /64. Yeah, that's right off the root. So we can do a link soft. Okay, so we want to link this guy. So this typically is the should work for us. Oh yeah, sorry, I got it the wrong way around here. Wake up. There we go. So now .NET. Okay, so it's not in our path. So I mean, for now, what you'd have to do is you'd have to put that in user local bin in your path. But for now, what we'll do, I'll just it was bin. That may be the new standard. So save that out. And we will give that a try. 3. Oh, yeah, of course. Broke my own rule. Let's see what happens now. and it actually worked. So let's kind of look at what we got here in the output. We'll just do a journal. There won't be much more info in there, but let's do a journal anyhow. You can see all our failures there. So what we did was when the console POC starts, it decrypts the file and we read according to these keys that we pass. So we want to read the connection string was the first thing. So you can see it is Dev Linux. That's the environment we're on. We read the Dev Linux secret 1, and then we kind of splunk down into the array and see the Dev Linux value and its value 4. So you can see it's the correct environment. The fact that we're outputting it means we're decrypting the file. And then you can verify. C3, let's take a look. I mean, the only file we have access to there is the secrets, and you're not getting at that. Oops, sorry. Would help, eh? You're not going to be able to get at that file. I can tell you that. That's the encrypted file. Of course, the salt's prepended to this as well. So essentially, we have a running POC with a full deployment, automated deployment over SSH, working. What else? I'm going to put all of these artifacts up into a GitHub repository for everybody to, and all as a package so you can download. Of course, you'll have to modify your script environment according to what directories you put your code in and that. The other thing I did want to mention was this is only a POC. Please do not use it in production. It has to be vetted, you know, through standard code review procedures and such. So it's just there to demonstrate the concepts that you can pick and choose and of what you want out of it. I wanted to mention, so this is one way to do it. There's a million ways to do it. This way you have more control over the different components, and it does demonstrate some different concepts like using a certificate, using the key, and using systemd in our case. So Microsoft does have a cross-platform, it's called the Data Protection Services for .NET. Now I had a quick cursory look at it, and I get the impression that it's, you know, primarily designed for kind of ephemeral keys like session keys and things like that, short-lived stuff. But I mean, I know you can set the lifetimes and you can do all sorts of things. It works kind of in a similar way. I don't think it uses systemd at all. Pretty sure it doesn't. But it provides a directory where only the service account has access to it, and it has key material and things like that you could store in there. So anyhow, I think that's it for this POC. If you like the video, please subscribe and hit the thumbs up. Until next time, stay frosty.